A very good afternoon to one and all present here in this call. I hope I'm audible. If there is any technical glitch, please let me know through the chat box in this Microsoft Teams platform. Uh, in the first half, we had a session by Dr. Shourab Mullik from the University of Arizona at United States America. And this time, in the second half, we have another session. Today, we have amongst us in this technical session Dr. Sumanta Ray from Sidho-Kanho University. Uh, Let me, before introducing today's speaker, uh, let me tell you that the joining link, we have provided this joining link at 2:45. Uh, and finally, the attendance link or the feedback link will be shared for both the sessions. Technical session 1 and 2 will be shared after the completion of this session, that is technical session 2. Please remember to fill out both the forms, as your forms will be taken into account for the final evaluation at the end of the session or at the end of this 1 week FDP. In this session today, we have amongst us Dr. Sumanta Ray. Dr. Sumanta Ray is currently an assistant professor in the Department of Computer Science at Sidho-Kanho University, Purulia. He completed his Ph.D. in computer science in 2018 and has over 12 publications in various SCI and Scopus-indexed international journals. His key specialization lie at the intersection of big data, machine learning, and federated learning, and he brings more than 10 years of teaching experience to his role. Dr. Roy has served in multiple capacities at Burdwan University, Sidho-Kanho-Birsha University, and other institutions, including as convener, chairman, moderator, and reviewer for various examinations. He has also been a convener, organizing secretary, and program committee member for numerous international and national conferences, workshops, and seminars. Additionally, he has delivered invited lectures at esteemed conferences, seminars, and workshops across the globe. Furthermore, Dr. Sumanta Ray has contributed to the academic governance of Sidho-Kanho-Birsha University by serving on the Board of Studies for both undergraduate and postgraduate programs. Today, in this session, that is technical session 2, Dr. Sumanta Ray is going to make his deliberation on machine learning using R. The title of this lecture is Machine Learning with R. In present scenario, as you know, R is the most widely used programming language for data analytics. Our speaker today is going to focus on the types of machine learning along with the fundamentals of R programming language, implementation of some selected machine learning algorithms using R programming language will be discussed in this session. Furthermore, one of the primary reasons behind R's popularity in machine learning and data analytics is its rich set of statistical computing and graphics capabilities. This is what we have got from the speakers, and this is a briefing of the upcoming lecture. Hope the upcoming lecture will definitely be a learnable experience for all of you, and this program would definitely bring in different critical thinkings. At the end of this very session, we would like to have questions from your end, as we had in the first session. The same kind of question answer session will be there at the end of the lecture. So feel free to write your questions in the chat box. We will take your questions, and definitely our honorable speaker will answer to the questions. It's now time for the lecture. Over to you, Dr. Sumanta Ray. And once again, a very welcome on behalf of IIC and EDC of Purulia Engineering and Technology College. Thank you so much for giving consent to this FDP and acting as a resource person. Doctor.
Thank you. Thank you so much for nice introduction, Dr. Ganguly. Am I audible, na?
Yeah, absolutely. You're audible. It's going fine.
Yeah. So thank you so much. Thank you for giving me this opportunity. So I'm directly showing my presentation.
Okay, let me turn off my presentation. Yeah, I've turned off my presentation.
My screen is visible, na?
Yeah, it's visible.
Okay, thank you. Okay, so this is the topic of my lecture. So we all know what is learning. So learning is basically how to improve the performance with respect to some experience or past data. So here, experience, past data, and historical data, they are quite same. So learning means we are going to improve our academic performance. We are going to improve the performance, not the academic performance. When we are going to improve our academic performance, then we'll be able to we will be able to develop some academical activity and so on and so forth. That means learning means we are going to improve the performance on the basis of some historical data or on the basis of some past data or previous experience. So there are so many definitions regarding machine learning. Well-known definition that is present, that is basically given by Tom Mitchell, and that is very interesting definition. Machine learning is a subset of artificial intelligence that we all know. Machine learning, deep learning, all they are the subset of artificial intelligence which uses algorithms that learn from data to make predictions. Not only the prediction, we'll be able to predict something, we'll be able to optimize something, we'll be able to conclude something by applying some machine learning algorithms. So there are the different types. That is very interesting: supervised, unsupervised, semi-supervised, and reinforcement. We all know. So in supervised, we will have the label data. Label data means in terms of some input attributes, we will have the output attribute, right? That is supervised. That means data is labeled. Output will be there. That is a supervised learning method. So unsupervised means that is completely unlabeled. No output data will be there. So what we will do by considering this type of data set where no output will be there? Here we will be able to find out the hidden pattern that is present behind that. So the difference in between supervised and unsupervised is that in supervised data we will have the data that is present over there that is completely labeled, and in unsupervised the data is not labeled. So labeled, not labeled means here output is present, here no output will be there. So in unsupervised, so what we will do by considering this type of data set where no output is there. So we'll be able to find out the hidden pattern that is present behind the data set. Here we'll be able to find all these things by applying supervised as well as unsupervised learning machine learning algorithms. And in semi-supervised, basically, here we'll be able to apply semi-supervised algorithm where data has been arranged, some data that are labeled and some data that are unlabeled. In that context, we'll be able to implement the semi-supervised algorithm. And reinforcement, basically, that is feedback-based machine learning algorithm, where if we will be able to choose a right direction, then we will be rewarded. Otherwise, we will be punished. So there are so many things that is present over there. There is a huge methodology that is present behind that. I am not going to discuss in details. So here there are the different categories under supervised. That means where the data are completely labeled under the supervised, we will have classification as well as we have regression. And in classification, data may be categorical or and in regression data are continuous. So categorical means here the answer that we will get, that is yes, no, or good, medium, average, something like that. That is categorical. Regression means that is continuous. So there are two categories. I'm coming in details all these things. So supervised, we have four different types of machine learning algorithms: supervised, unsupervised, semi-supervised, and reinforcement. And there are the different categories of supervised. That may be classification, maybe regression. So classification, that we will be able to judge only by finding the categorical variables, and the regression we will be able to judge by finding the continuous variables. And in unsupervised, we have clustering, we have association rule mining. All these things, clustering means we'll be able to make a cluster. We'll be able to make a group, and in association, we'll be able to generate some item set, frequent item set. We'll be able to generate. So basically, we mainly focus on. Listen, there are so many algorithms that is present under supervised, under unsupervised, under reinforcement, and under semi-supervised. So basically, we focus on some specific algorithms that is under supervised and under unsupervised. So how the algorithm will work and how we implement all those algorithms by using R programming language. In my lecture, I mainly focus on this specific topic, that what are the algorithms that is present over there. I am going to choose some selected one. What are the algorithms related to that, and how we will implement all those algorithms by R programming languages. Okay, we mainly focus on that. So before understanding this algorithm, maybe supervised, maybe unsupervised, before understanding all those algorithms, we should have clear idea on R. Okay, so R is also a, one type of programming languages that is open source. We can easily download that. Mm, and that is most widely used programming languages for data analytics, right? So so if you want to install R, so there are two different terminology that is present over there. First one is R console, second one is R studio. Got it? So in R studio, if you want to install R studio, that is better. First we install R console, then we install R studio. Got it? So R studio basically has 4 different windows. R console is one of them. So if you want to install R in your system, first we have to install R console, then we have to install R studio. So they are quite same one specific function or one specific program. I am writing in R studio and I am writing in R console, and definitely we will get the same result. So there is no basic difference in between these two, R console and R studio. So why will you go for R studio or why will you go for R console? R console basically one Windows, okay, and R studio has 4 different windows. R console is one of them. So apart from this specific R console, R studio has some one specific say historical background, one specific plotting part, one specific notepad. There are so many things that is present over there. So the conclusion is that if you want to install R, better first we install R console, then we install R studio. Because in some cases R studio will not work without installing R console. Okay, so there are some these are some basic equations. So I am showing you. So initially you can choose any version in Google. In Google, you just type R studio or you just type R console. That's all. So no upper version, lower version is different. You can choose any one, any version you can choose. Yeah, that is R studio. R studio has 4 different windows. That is the first window. This one is the second window. This one is the third window, and this one is the fourth window. And R console, that basically looks like. R console. Okay, R console is not here. You can easily install R console from the web. So you just type R console here. You can choose any version. You can choose this one. Okay, it will take more time, no problem. Okay, so that is basically R console looks like this one. That is basically console. Okay, so here you can type your function, you can type your program, all these things you can type here. You can also type your function or your program here. Also you can type. Say I am writing say print hello. In this way, you can run directly. You can type your comment here also. Say, yeah. In this way, you can type your comments. That is working. No problem. So they are the different functions, or they are the different comments. If you want to find out the value of this one, you just type it and you will get the value. You are going to find out the square root of 2, you will get this one. Sequence is one interesting topic. Sequence means if you write SCQ, you will get all these things. Instead of this one, if you write SCQ of, you will get these things. That means here you have mentioned the interval 0, then 2 will come, then again 2 is incremented by 2, 4 will come, and so on and so forth. That is the role of sequence. Okay. So if you assign one extra parameter, say length equals to say 6, you will get this things. Instead of 6, if you write 2, you will get only 0 and 5. Instead of this one, if you write 3, you will get this. So there are so many things you can. You just type this function, and you will get the answer. So this one is your exact function, and this one is the answer. All right. In this way, you will be able to generate all these things. And in R, if you are going to assign now, so you can use say a equals to 5. You're going to find out the value of a. So the value of a is 5. So instead of equals to sign, if you write less than minus 5, then also you'll be able to find out the value of variable a. Okay. So in case of assignment, you can use equals to sign, or you can use less than minus signs. Less than minus sign. Here, one interesting thing that is basically this specific features that is available in R. If you write x comma y, then equals to 1 comma 2, or if you write x okay, you are going to find out, say in R, two main basic concept that is present over there. First one is vector, second one is list. If you want to find out a vector na, then you have to use C sign. You are going to find out, you are going to declare a vector that consists of 3 different elements that are 10, 20, and 30. So C is the keyword. You have to use C, right? So here that is the integer vector. Here, if you want to declare another one vector, and the vector has integer element as well as some string element or character element or text element, that also you can do. Yeah, in this way you can. So here, basically A, here you have assigned one specific variable inside the vector, that is x. So and earlier you have assigned this variable by 5. So here 5 will come. So instead of this, if you write a and a enclosed in single inverted comma, and then the x this specific vector has 10, a, and 30. Are you getting me what I'm going to say? If you assign a equals to 10 and you are going to declare one vector, say c of 1 comma a comma 2. So here the result of x is this one, because a, this variable has already been assigned by 10, and here you are going to declare one vector, that is, say you have 10, you have b, and say you have a, and say you have 20. Now what we get? Okay, so that is the string vector and that is the normal vector. Got it? Normal vector, string vector. So here, if you are going to assign, if you are going to represent one specific character or string or text, maybe enclosed in single inverted comma, maybe enclosed in double inverted comma. Both are equal. You just check it out. Instead of double inverted comma, if you assign here, say distance, here also you will get this. So single and double both are equal. Okay. And one thing is that there is list. It is the list is the basically reverse of this, reverse of vector. Okay. So you are going to declare one list, and that consists of 3 different elements. And okay. So why is this one? So that is the first row, first column. This one is the second row, first column, and this one is the third row, first column. Okay. So X is the vector, Y is the list. So here you will be able to unlist a list. That means it become a vector. You will be able to unlist a list. That means it will be a vector. So how you will be able to do that? Suppose S equals to unlist of Y. So what you will get? S equals to this one. So it's become a vector. So there are so many equations, so many things that is present. All these things that is present in this slide. Sequence by. Here also you can give by. Okay. That is a vector. You can add 2 different vectors. You can also add 2 different vectors. Suppose you have declared one vector that has 1, 2, 3, and another vector that has 2, 3, 4. The result will be 3, 5, and 7. Okay. You can add 2 vectors. So there are so many operations. You will be able to find out maximum, minimum. You will be able to calculate the length also. You will be able to find out the mean. Okay. SQRT for that means here if you want to find out the square root of this specific value, you'll be able to do that. Okay. Yes, some logical variables that is also present over there. Suppose logical means suppose you have assigned 10 on A, you are going to check. Now you are going to check A equals to 10. Answer will be true. If you write A equals to 11, answer will be false. So these things that is present over here. Here you have assigned one specific string inside this variable. The dog ate my homework. So here you are going to change this specific word by cat. So if you use this specific function sub function, by using sub function, you will get this result. Okay. You can add a vector. Suppose one vector that has the elements 1, 2, and 3, and you are going to add. You are going to multiply the complete vector by 2. Then definitely you will get 2, 4, and 6. Okay. There is a list. Same as vector, within the list, you will be able to assign some string value. That means homogeneous parameter, heterogeneous parameters you will be able to consider. Okay. Suppose you have declared one list, or name is this one. That means say you have declared one list, say, and the list has name equals to, I am telling Ajoy. Okay, role equals to, I am telling that is 1. So if you want to find out the name that has assigned on A, so you just write A dollar name. You will find out. So all these things you will be able to do by going through these slides. Okay, I am sharing this slide after my session, so you'll be able to do that. Is to means here also is to means you will get the complete numbers. So list of 1:5 means what you will get 1, 2, 3, 4, 5. Okay. So all these things that is present over here. You will be able to declare a matrix. So that is very interesting. Matrix means if you want to declare a matrix, matrix keyword is being used here. Say 1:6. The matrix looks like this one. Instead of that, if you write number of column equals to 2, then you will get these things. If you write number of column and number of in col means number of column, in row equals to 3, then also you will get this one. You can change this. Row equals to 3, column equals to 3, row equals to 2. Okay. In this way, you will be able to do all these things. That has all that has been defined in my slides. I'm sharing all these things. So here, 2:3 means suppose you have defined a huge amount of data set. You have declared a huge matrix, say 100 into 100 matrix. You have already defined. From there, you are going to extract some rows, some specific rows, and some specific columns. You will be able to do. You will be able to do all these things by writing all these comments. Here, I am considering a simple matrix. If you have a huge matrix, then I will be able to do all these things. Say, I am writing this one. That means you are going to display the second column. In second column, you have 3 and 4. If you add minus here, then excluding the second column, the complete matrix will be displayed. Okay. So all these things that is present over there, you just try it. I am sharing all these things. And here in R, that is very interesting. If you want to find out the transpose of a specific matrix, so X, you have this one. If you want to transpose of this matrix, say y equals to T of X, T of X. So T is the keyword, T for transpose. So now y is the transpose of X. And if you want to perform addition, subtraction, multiplication, division, you'll be able to do that only by giving the sign. Say X and Y, these are two different matrices. If you want to multiply, you just write X multiplied by U. Multiply the multiplication sign Y. X division sign Y. X plus Y. X minus Y. In this way, you'll be able to do all these things. Here also you can declare an array. Dim for dimension. If you want to find out, you don't know what is the exact dimension. Say you have collected so many primary data and you have stored all those data in a R file. You don't know what is the exact dimension. So in that context, if you write here y is one matrix, so you just check it out. If you write dimension of y, you'll be able to find out the dimension. Not only that, if you want to find out the number of columns that is present over there, you'll be able to do that. Number of row also you'll be able to calculate. In this way, you'll be able to generate all these things. So everything has been defined here. You just try to solve all these things. You have the function, you have the comments as well as the corresponding output that is also given here. You just try it. Okay. And here one interesting thing is that is data frame. Say you are going to store some primary data. So inside A, you have say 1, 2, 3, 4. Here. So they are the 4 parameter values that is present inside one variable, that is A, that is present inside one vector, that is A, and inside another vector, you have some specific values, say all these things. Okay. Now you are going to design a data frame, data dot frame. If you write all these things, then and what will be the output? That is the output. So you can design a table. You may have say n number of parameters. In this way, you can by using the data dot frame command or function, you'll be able to do all these things. So everything has been defined here. You just check it out. And here, say if you want to find out the value of a specific column, you just write X, then the dollar sign. Then if you write A, you'll be able to retrieve one specific column. Okay. So everything has been defined here. You just check it out and try to solve all these things, and definitely you will get the output as well as a result. Okay. So here you will be able to implement if else. You just write all those comments. You all know else is optional. Here also you will be able to implement all those things. If else, for loop, while loop also you will be able to implement. You all know what is that. Okay, so that is clearly written here. So you just try to solve all these things. I just want to switch on the uh, cream topics. Okay, so everything has been defined here. Uh, Okay, say in R, how to import a data set. In R, basically, you will be able to import different type of files. Maybe a CSV file, maybe a Excel file, maybe a doc file, maybe a stata file, maybe a views file, maybe a SPSS file. You will be able to import all those data set in R. That is possible. So I'm just showing you how a CSV file you will be able to import in R. So CSV file means that is comma separated values. How you create a CSV file by using Excel, you will be able to create a CSV file. Say in Excel you have all these things. Say in Excel, suppose you are going to write name, then role, and then marks is there. Say you have A, you have 1, you have 20, and here you have B, you have 2, and you have 30. Now you are going to save. Save as desktop. Here you write the name. Say I am giving the name HG. I am giving say HOOGHN, Google. Okay, and here that is the here you have to select comma delimited CSV for comma separated values, and it returns in desktop. Okay, so in desktop what you have Googly that is coming. Yeah, that's a CSV file. There is a differences in between CSV and Excel file. In Excel file, basically the icon of Excel file that looks like this one, and there is the CSV file. A is written here. In this way, you can create. There are so many options. So by using Notepad, also you can create a CSV file. Say in Notepad, Notepad. So here, if you write name, comma, role, comma, they're the parameters, right? They're the attributes. Name, comma, role, comma, say marks. In here, if you write comma 20 and B, comma 2, comma 30, and here you just save it. Save as. You just keep it in desktop. Here you write Googly 1, Googly 1.csv. Here you select all files, right? So in desktop, Googly 1, it's a CSV file. You just check it out. Yeah. In Notepad, basically by using Notepad, I have created this file, and by Excel also, by using Excel also, we'll be able to create a CSV file. Now, how to import? There are so many techniques to import a. There are so many techniques associated with that to import a CSV file in R. So here. There is the fast technique and more easy technique. That is, here you just type. So GTWD for get working directory. So that is the exact path. So I am working in a that is the path that has been selected. That is document, but my file that is present in desktop. So you have to change the path. How that will be changed? Here you have to write set WD for set working directory, and here you just copy this path and you paste it. Okay, and here you have to, instead of desktop, you have to write, instead of document, you have to write desktop. Okay. Now, inside A, inside the variable A, we are going to store the file that is Googly. Okay. So So read.csv is the function to import the file. So that is purulia.csv, and that must enclosed in double inverted comma. It has already been imported. So here you can see this A by writing A or by writing view of A. V must be in capital letter. Okay. So here the file is already been viewed here. That is the first technique, and another one technique is there. That is, if you write B equals to, here you just write read.csv. Inside the bracket, you just write file equals to. Here, you just copy the path. So that is the properties. Here you can copy the path. You can copy the path and you paste here. Now you have to change the slash. Okay, the file name is html1.csv, and here all the path must be changed. You can ignore the warning, nothing issue about that. If you type B here, yes, you will get. Okay, so in this way you can import a CSV file. There are so many techniques that has already been written in my slide. How to import a Excel file, how to import a XLSX file, how to import a SPSS file, how to import a eViews file, how to import a SCADA file. That has all that has been clearly written in my slides. Okay, so you'll be able to find out how many number of row and how many number of that I have already explained. How many number of row, how many number of column that has been present over there. You'll be able to find out. Okay. Now the interesting fact is that suppose you are going to find out, you are going to generate some subset from the existing data. That is possible. Suppose you have this data, and from the data you are going to find out, say in B you have A120 and you have B220. From B you are going to generate one subset. I am working with a small file, na? That's why that will be more difficult to explain. Okay, no problem. I'm going to find out the subset of B. Okay, suppose say I'm going to find out the subset from the file where the marks is greater than 20. How that will be retrieved? Say x equals to subset of B where marks is greater than 25. Got it? So what will be the result of x? This one. That is the cream of art. Okay. So all these things that has been defined here. Okay. You can add some clause. You also some add some clause or some clauses. You'll be able to add and all these things. Now, one more thing. Suppose you have already created a CSV file. You all know how to create a CSV file, how to import a CSV file. Listen carefully. And from the CSV file, if you are going to generate a subset, okay, and you are going to store this subset inside another one CSV file, how you will be able to do that? So by using write.csv command, you will be able to do that. So what is that? You just check it out. Say here you have B. From B you have already retrieved one subset, that is X, and you are going to store this X inside another one CSV file. So what will be the corresponding command? Say inside Y you are going to store this. Am I audible? Am I audible?
Yes, sir. You're perfectly clear.
Yes, audible.
Yeah. By using write.csv, you just type here x, and here you just give a name.
Sir, just wait a minute. You're muted. Just wait for a second. Sir, can you just mute and unmute again yourself from your side?
Am I audible?
Yeah, yes, sir. Yes.
Okay. So can I continue?
Yeah, yes, sir. Yes, sir. Please continue, sir.
Okay.
Sorry, sir, for the inconvenience.
No, no problem. No problem. Okay, so suppose you are going to work with some secondary data. That's a huge amount of data that is present inside the web. So directly from the web, you will be able to import a data into R. That is also possible. Okay, so you just in this specific site, I have one data that is titanium.csv. Okay, so if you find the data set in this way now, so directly you can write all those comments. Directly you will be able to import that data into your R platform. That is possible. Okay, so regression that I will discuss later. So that is very interesting. SQL, we all know some SQL. SQL means we have a data that may be in different table or maybe in one table, that may be heterogeneous data, that may be homogeneous data. We are going to retrieve one specific data in terms of my choice. Okay, suppose, and in R also you'll be able to write the SQL statements. By using the SQL statement, we will be able to retrieve the data from the existing data set. Okay, suppose we have one data. Say we already imported. Actually, in this desktop there is a no huge amount of data. I have only the small data set. Okay, no problem. So if you are going to write the SQL, na, you have to import some packages. In R, basically, uh, when you are going to write some complex program, write some complex statements, complex functions, you have to import some packages. They are constant packages. Without packages, you won't be able to implement all those functions. That is basically present inside that. So if you want to write some SQL statement, you have to install one package that is SQL package. And how to install the package in R? So one command is there, that is install dot packages. Okay, the command name is SQL PACKAGES. That is working. Yeah, that has already been installed. Okay, that is not quite enough. After installing this package, you have to call library. Okay, and you have the data set A. Suppose from A you are going to find out all the details that is present inside it. Say is equals to SQL df. Here you just write select star from A. Yeah. Instead of this, that means you are going to find out all the details that is present inside A. Here, select star from A. Select. If you write select rule from A, what is the result? That is the result. Got it? If you write say what will be the result of S? This one. Okay. So in this way, you will be able to write SQL statement in R. Got it? Not only that, here you can also write some complex programs. Say oh, marks has been assigned there as MARTKS. That's why it is not working. MARTKS. Yeah, now it's working. Okay. So in this way, you can write some simple query also in R. Okay. So everything has been defined here. Now I am going to discuss one specific. Say there are so many supervised algorithms that is presently available. Okay. So in supervised, we have so many algorithms. We have neural network, we have SVM, we have KNN, and unsupervised also. We have k-means, we have different types of clustering, say partitioning, hierarchical. Inside the hierarchical, we may be agglomerative, divisive. So there are so many algorithms that is available. I'm going to show you some algorithms as well as their corresponding implementation using R. Okay. So k-means, what do you mean by k-means clustering algorithm? So k-means, in k-means basically, you just check it out.
Uh, Excuse me, sir. I think your audio is muted.
Now, am I audible?
Yes, sir. You're audible now.
Yeah. I'm telling there are so many algorithms that is present inside supervised, unsupervised. So initially, I'm going to discuss one specific algorithm that is nothing but the unsupervised algorithm. What is that? What is the mathematics of this algorithm? And what is the implementation? What is the exact implementation of this algorithm by using R? How you implement this algorithm by using R? And further in research, if you want to develop this algorithm, how you change the equation, how you change the different codes, you will be able to do that. I am considering one simple 8 observations. So in first observation we have 1, 1, second observation we have 1.5, 1.5, and so on and so forth. So we are going to plot all those XY values in terms of Excel, and in Excel, if you plot all those observations, this Excel sheet basically looks like this. That means you can directly conclude, yes, we have 2 different clusters. We don't have 3 or 4 different clusters. By contradiction, you can say, yeah, we have 4, 5 number of clusters. That is possible. But initially, if you plot all those observations by using this Excel sheet, you will find you will have only 2 different clusters. Okay. Now, what is the mathematics? So mathematics is that you have to choose 2 random points. 2 random points. So here I am choosing 1, 1, and 3, 3. Okay, I am choosing 1, 1, and 3, 3. Yeah. So I am choosing the first observation, that is number 1 observation 1, 1, and I am choosing the final observation, that is 3, 3. Got it. Now what you will do? You have to calculate the distance in between first random point to all the observations. That means I have chosen first random point, that was 1, 1. So the distance in between 1, 1 and 1, 1. So definitely that will be 0. The distance in between 1, 1 and 1.5, 1.5. Distance in between 1, 1 and say 0.5 and 0.5. And I have basically calculated this distance by using Euclidean distance. So Euclidean distance means x2 minus x1 root over whole square plus y2 minus 1 square root over of that. In this way, I have calculated the distance in between 2 points. Okay. So the distance in between 1, 1 to 1, 1, that is 0. 1, 1 to next one, that is this one. 1, 1 to next one, that is this one, and so on and so forth. So that is the first distance metric. And in second distance metric, I have chosen the second random point, that was 3, 3. So distance in between 3, 3 to 1, 1, that is this one. 3, 3 to next one is this one, this one. And final one observation was 3, 3. Final one observation was 3, 3. So the distance in between 3, 3 to 3, 3, that is 0. Now, you have already got 2 different distance metrics, that is distance 1 and distance 2. Okay. And here, if the first distance is less than the second distance, then you just assume that belongs to first group. That I am I am assuming actually. You can assume in a different way, that is also possible. Okay, I am assuming that the first distance, if the first distance is less than the second distance, then that must belongs in first group. Okay. So in this way, 0 less than this one first group, this one less than this one first group, this one less than this one first group, this one less than this one first group. And in fifth observations, that is greater than this one. That means that must belong in a different group. That is group number 2. Okay. In this way, you'll be able to find out 2 distance metrics as well as their corresponding group or their corresponding groups. And in next step, what we will do? In next step, you have to find out the mean of distance 1 and find out the mean of distance 2. That will be the next random point. first random point that you have chosen. Here I have chosen 1, 1 and 3, 3. Then I already have calculated the distance metric as well as their corresponding groups that I have calculated. And in first group, you will be able to find out the mean of distance 1 and mean of distance 2. That is the second random point. Got it? And mean of distance metric of group 2 and mean of distance 2 metric of group 2, that will be my second random point. So the mean of 0 plus this one and plus this one plus this one, that you will get the x value. This one plus this one plus this one plus this one divided by 4, that your y value. So that is the second random point. And again you have to choose another one random point. So this one is this one plus this one plus this one plus this one divided by 4, second random point. Here also this one plus this one plus this one plus this one, that is the second random point. So I have calculated 1.075, 1.05 and 3.095, 3.415. These are the two random points, two observations, two random observations. Okay. Then also we have to calculate the distance in between 1.075, 1.05, 211, 211, 1.15 and so on and so forth. Here also that is stored another one distance metric, and the distance in between this random point, this observation 3.095, 3.145 to 1.5, 1.5. In this way also you will be able to find some distance values. Got it? And again you have to make a grouping. If the first one, that means first distance value, is less than the second distance value, then that must be in group 1. If the first one value is less than the second one value, that must be in group 1. But if the first one is greater than the second one, then that one must be in group 2. In this way you can make a group. But here no changes there. No changes there means in first cases, first 4 observations, first 4 distance was in group 1 and second 4 distance was in group 2. And here also, by finding the second random point also, when you are already find out the distance, here also first 4 distance in group 1 and second 4 distance in group 2. Then we will be able to conclude, yes, in this specific data set. Any question? Any question? Okay. So in this data set, you will be able to conclude we will have 2 different clusters. Got it? We have 2 different clusters. So here, if we will get a different answer, that means different grouping. Now again, we have to find out the mean, we have to choose the random point and so on and so forth. In this way, we will be able to calculate, we will be able to implement the k-means algorithm. That means how many number of clusters that is present over there. That is the main motto. So how many number of iterations that is present over here? 2 number of iterations. So only 2 clusters that is present over here. Now, what will be the implementation? When you are going to implement this k-means, how that will be implemented? You just check it out. See, in R, there are so many inbuilt metrics that is present over here. IDC is one of them. Metcars is one of them. So you just check it out. If you write IDC, yeah, that is the inbuilt data set that is present over here. 150 number of instance, 150 number of records, and 5 number of attributes that is present over there. So that is basically IDC is one type of flower in terms of spatial length, spatial width, petal length, and petal width. We will be able to judge the flower is setosa, versicolor, or virginica. 3 different classes that is present over here. That is present basically. Okay. So if we don't have the final column, That means we don't, if we don't have the final class column, that means here we have the final class column. That means here this one is supervised. We'll be able to implement some supervised algorithm. That means in terms of all those 4 parameters, what will be the final one, that we'll be able to predict. But here, if we ignore the final column now, then that one is unsupervised. Then if we apply on, say, if I have the data set, say I have the data set. Here, by writing this command, I am ignoring the final column. Okay, so here, so we are very familiar with this data set, that is inbuilt data set present inside R, and we all know 3 classes that is present over here. But if we ignore the final one, we don't know how many number of classes that is present over here. So by applying k-means, we will be able to find the number of classes, find the number of groups, find the number of clusters. How you will be able to do that? If you are going to implement the k-means clustering now, you have to install some packages. Okay, one specific package is there, that is cluster. Install dot packages. Here you just write cluster. That is installing. Okay, and here if you write install dot cluster R, C and R, these two are in capital letter. That is also working. Now you write library, that is cluster. That is cluster R. You can ignore the warning. Okay. And here in k-means on say in terms of this specific file, if you are going to apply k-means now, you just write. So if you want to implement k-means clustering, you have to install 2 different packages. First one is cluster, all there in small letter, and second one is cluster R, where C and R both are in capital letter. Okay. Now inside X, you just write k-means here is the actual data set. Okay. You know how many number of cluster is there. Here we all know how many number of cluster that is present over there. That's why I am considered 3. If you don't know how many number of cluster that is present over there, then you have to apply the elbow method. One elbow method is there. By applying the elbow method, you will be able to find out how many number of cluster that should be present here. By applying the method, you will be able to conclude, yes, that will be 2, 3, or any other number. Here I know that is 3, that's why I am inserting this one. I'm not switching the elbow method, but that is, it will take more time. That's why I'm writing 3. Okay. Now, if I write X now, say that is the first observation, that is in cluster 1. That is the 37th observation, that is in cluster 1. In this way, there is a 145 observation, that is in cluster 3. That is 46, 47, 48, 49, 150. That means 150 observation has already been served. That is the cream of art. So what we had this A. We had the data set, that is A. Inside A, we have 150 observations. Okay. And among all those observations, which observations fall into which cluster? Got it? So 1 means they're the same category, they're the homogeneous observations. 2 means They are one type of homogeneous observation. C means that is also one type of homogeneous observation. Okay, and that is the main thing actually with three. Okay, I am ignoring this one. That is the main thing, because here, if you want to apply, if you want to find out this three, you have to apply Ilgo method. Okay. So one more interesting algorithm that is present inside your say supervised. There are so many algorithms in unsupervised. I am just showing you how to implement all these things in an easy way, and you'll be able to develop that by using R. Okay. Same principal component analysis, that is also unsupervised learning method. So in PCF, what you are going to do in principal component analysis, you are going to find out, you are going to extract the features. That means the definition of PCA is that say in PCA, PC is a method that reduces the data dimensionality by performing the covariance analysis between the factors. That means if you have n number of attributes, you will be able to optimize all those attributes. The main goal of PCA is that, say, maybe conclusion, maybe optimization, maybe prediction, all these things. So in PCA, that is one example of unsupervised machine learning algorithm. PCA, there is a well-defined mathematical algorithm that is present here to find out the principal component analysis. So if we have a table and the table has some indicators, PCA basically wants to find out what are the more important one and what are the less important one. Okay, so that is the main role of PCA. Say you are going to explain the student, you are going to evaluate one student in terms of n number of parameters. So PCA tells n number of parameters, all the parameters are not more important. Some of them are more important, some of them are less important. So basically PCA basically wants to find out the more important one as well as less important one. So one mathematical algorithm that is present over there in PCA, if you want to find out the PCA by using R, not in R, the algorithm is that first you have to find out the covariance matrix. So covariance, correlation, and cross correlation, these three are completely different. But in R, if you want to find out the covariance matrix, if you want to find out the cross correlation matrix and correlation matrix in R, you will get the same result. Okay, so in PCA, if you want to find out the PCA, first you have to find out the correlation matrix. Then you have to find out the eigenvalue as well as eigenvector of this correlation matrix. Then you have to plot all those eigenvalues. By seeing the eigenvalues, you will be able to judge what are the more important. You just choose the more important one, as well as with respect to all important parameters, you just going through the eigenvector matrix, and you will be able to find out what are the more important one, what are the less important one. Okay, I'm just telling you how PCA will work. Say I'm showing you. Okay, so video is on. Okay. I'm just showing you. Say I have the data set A. Okay, we're going to find out the correlation matrix of it. How to find out the correlation matrix of it? You just write COR of A. Listen, correlation matrix means all the diagonal elements that are 0. All right. Now, if you want to find out the eigenvalue of B, yeah, all that the eigenvalues. Got it? So if you have phone number of parameters, you must have phone number of eigenvalues. And if you add all those eigenvalues, you will get 4. If you have a relation that has 10 number of parameters, and if you want to find out how many number of find out the number of eigenvalues, you will get 10 number of eigenvalues. And if you add all those eigenvalues, now you will get 10. Okay. And if you have a correlation matrix that is 10 into 10, and you are going to find out the eigenvector, that in that context also you will get eigenvector that is 10 into 10. Okay. So now you have to plot all those values, eigenvalues. You will get a graph. In terms of all those graphs, you will be able to judge what are the more important and what are the less important. Got it? So you have to consider these eigenvalues as well as all those eigenvectors, and by using graph you can judge what are the more important one. Okay. Apart from this specific criteria, there are so many options to find out the PCA in R. That is one option, step-by-step solution. Another one solution is that is hack to extra, one package that is available. Hack to extra. That is hack to extra. It will take more time. Okay, so by using fact to extra, you can directly apply one specific function, that is PC. Okay, that is present in my slide. You will if possible, you will try it later. Now I am showing you one. So I have already explained two unsupervised. First one was K-mean, second one is PC. Now I'm going to discuss one supervised learning algorithm, that is KNN, K nearest neighbor. So in K nearest neighbor, basically the concept is that in K nearest neighbor, say we have so many observations. Okay, we have so many observations, and all those observations that must belong a specific class. Say x1 belongs to C1, x2 belongs to C1, x3 belongs to C2, again x3 belongs to C4, and so on and so forth. If one new observation that is came into the system, then it will belong in which class, that you have to predict. So that is completely supervised. That means this observation must belong to this class. So if one new observation come into the system, in which class this observation will belong, that you have to predict. Got it? So that is the mathematics actually. So mathematics is that you have to find out the distance in between new observation to all those observations, and then you have to arrange all those distance in an ascending or descending order. Okay, now you have to make a couple. So there are mathematics that is present behind that. So by using R, how you implement that? Okay. Say for KNN, you have to install two different packages. First one is class, second one is caret. Okay. Second one is caret. Yeah. Now I am showing you. Say I am creating one CSV file. Say, and there are parameters A, B, C, D. In terms of all those parameters, that is the result, right? Suppose if the parameter is 10, say 9, 8, 7, then the output is good. Okay. If the parameter is in this way, that has been arranged there. Say if the parameter is 1, then 2, then 1, then 1, then 4. Here also, if the parameter is 9, say 8, 10, even 10, that is good. Here, if it is 8, 9, it's 10. Is 1, 1, 1, 1, 4. Okay. Here you have required one trained data set, one tested data set. So that is the trained data set. Trained data set means you just assume they are the different parameters to assess a student. Okay. So say A for regularity, B for discipline, C for say dress code, D for communication skill. In terms of all those parameters, you can conclude the student is good. And in terms of all those parameters, student is poor. In terms of all those parameters, student is again good. In terms of all these parameters, student is good. In terms of all those, student is good. That is your original data set, trained data set, historical data, past data, experience data that you have. Okay. Now you just save it as a CSV file in desktop. Say a test. Okay. We just trained. You just save it in desktop. Here, this one is file. Okay. Just save it. That is K-train. That is your historical data. Now you are going to find out another one. Say you have A, you have B, you have C, you have D, and this one is the result, right? And the value of A is 10, 9, 9, 9. Here you write 4. Okay. And 1, 1, 1, 1. Here you just write. That is your tested data set. Here you are considering some fake values. Got it? I am working with a very small amount of data set. Small data set, small amount of data that is present over here. I'm considering a simple one. But if you have a huge amount of data, say you have 1 billion data that is present in your trained data set as well as your tested data set. Now what you will do? So my main motto is that I have one historical data or experience data that I have created earlier. That means in terms of all those parameters, the student is this. So here, that is a new data set. That is a tested data set. So in terms of all those parameters, what will be the value of this final column? That is R. What will be the value of that? That you are going to judge. Okay, that you are going to judge. With respect to all those values, what will be that? But in R, you have to fill the value with some fake values. Maybe correct value, maybe incorrect value. You have to fill that. Now you just save it. That is your tested data set. Here you write, say, that is K test. Okay. So main motto is that with respect to this table, that is trend, that is already trend. With respect to the data set, what will be the value of this tested data set? That we are going to find out by applying k-nearest neighbor. So for k-nearest neighbor, we have to install two different packages, caret and class, that we have already installed. So here we have to import these two data files. So inside A, we are going to store the first data set, that is k-trend. Trend.csv, and inside B we are going to store the second data set, that is test.csv. Now you are going to write the comments, say KNN. Here you just write train equals to A, test equals to B, nothing doubt about that. CL means classification. You are going to classify in terms of the final column. That means string $R. That was the final column. And here you just give the k values equals to 3. Why that is 3? Instead of 3, you can give the 2 also. So here also the value of k is required. K is optional. K is required. Right? Instead of 3, you can also give the 2. You can also give 2 also. So sorry, that will be $R. $R. And that is where train is that is the first data set, that is the second data set, and here for classification you are going to choose. Okay, no problem. Class we will carry so string equals to a dot r. Okay. So instead of AB, you need this one is X, this one is Y. That is the classification in terms of $R, 3 equals to 3. This one is error. Sorry, any question? Any question? Am I audible, na?
Yes, sir, you are
Yes, sir.
absolutely
Yes, sir. You are audible.
Yeah. Thank you. I am checking the code. You just give me 1 minute, okay? That is not working. Why it is not working? I am checking. Okay, you just give me 1 minute, please. Oh, with respect to the final one, we have to choose. Final one was A, B, C, D. Final one was -5, right? So this one is -5. Here also this one is -5. This one. Now definitely that will work. Okay. Yeah. Listen, in my data set, first data was poor, second data was good. Okay. Here, after applying this one, first data is good, second data is poor. Okay. Are you getting me? Here in tested data set, first data, the result of first observation was poor, and the result of second observation was good. But after training KNN, after applying KNN, the result is good and poor. That is the drastic change. That is the, actually one voice is coming. That is the drastic change. That is the Am I audible?
Yes, sir, you are audible.
Yes, sir, you are audible.
Yeah. So that is the cream of part. That was my tested data set. That was my trained data set. That has already been trained. If the result is this one, definitely that will be good. And that is my tested data set. I don't know what will be the output.
নেটের অবস্থা এত খারাপ
We have to feel all these
এখানটা
things
দেখো এই যে
by
এই যে ছবিটা
different
দেখো।
fake values. Okay. Here, if the value is 10999, I have assigned poor, but that must be good. Yeah. Here in R, I have applied KNN. For KNN, two different packages is required. First one is caret, second one is class. By applying all these things, I have imported these two data set, and if I write this command, -5 means with respect to final column. This one is the final column. That means 1, 2, 3, 4. This one is the final column. With respect to this final column, the result will be decided. Okay. And here CL for classification equals to $8R. That means with respect to the final column, we have to decide. Okay. So that is the result. If you go for say KNN classification, K nearest neighbor classification. Okay. So I'm just showing you one final thing, that is, if you are going to apply disease entry, that is very easy in art. In that context, you have to install two different package, party and party kit. How that will be installed? You just write packages party and you write party kit. Okay, so I have one IDs data set. So if I apply this data set, so C3 is the keyword, right? Species, that is the column that is available inside the IDs data set, and that is the final column, that is the class species. Then tilde, then dot, then comma, then data equals to IDs. If I write A equals to IDs, Mm,
Okay, so we are done with the presentation.